Welcome to my channel. Today, let's have a deep think about space and space travel. First, relativity theory says you can't travel faster than light. Second, relativity theory says energy is limited to the speed of light. Third, relativity theory says mass increases as a vehicle approaches light speed. Fourth, particles like protons have a speed limit but tells nothing as they appear in superposition. 5. Relativity theory says gravity is a curvature but doesn't say what gravity is. 6. Relativity theory says light bends, coupling to the space grid, travels up and around space curvature called gravity wells, but says nothing about their particle atomony. Is bent light just particles in a bending path close together? Koetsky takes all these inclusions in his quantum physics theory interpretation. Nothing is left out. Superluminal transportation on an expanding grid that us faster than light coupled to that grid can travel at any speed it has capability to. Fact. Gravity is universal particles called nodes that exist at the Planck scale 10 to 30 power. Fact, vehicles in space lost their mass, leaving the ship as an empty shell in space. No mass, no gain. Fact, energy is conserved. The bigger the motor, the faster the thrust. Fact, relativity theory, gravity wells are straightened due to expanse. It takes 2 pounds of energy to push a single pound mass. Fact, in space, where our ship loses its mass and becomes a mechanical shell, the 2 pounds of energy, noting that the ship supports Lightspeed warp drive motors, will travel twice light speed. Why? Fact, because it loses its mass, its weight, and uses the 2.1 ratio energy. Even though this seems futuristic, it is in the cards. It violates no physics hypothesis and is embedded in our Earth mathematics.
Myth. The vacuum is nothing, empty. Koecki's claim. The vacuum is made of quantized molecules of space that underlie everything. At the Big Bang, all matter was packed into its smallest units, and those units still coexist inside everything today. So what? If space itself is chunked, then nothing is actually the most important something. Myth. To go faster than light, you have to warp space or do time travel. Koecki's claim. You don't bend space, and you don't go back in time. His reverse vacuum space field drive would ride a repulsive vacuum tied to the Hubble expansion, so a ship could move superluminally within our standard universe. In his view, cosmic expansion isn't just background, it's the engine. Myth. Faster than light travel would automatically enable time travel paradoxes. Koecki's claim. If you can exceed light speed by coupling to the expanding vacuum, then classic time travel tricks collapse. In the cosmic core, he argues the universe's expansion rewrites the conditions that link FTL and time travel, breaking the usual paradox loop. Myth. Einstein's relativity is mathematically airtight for all cosmic journeys. Koecki's claim. In Albert Einstein's universe, he says relativity does not conform to a formula that pans out for time travel coordinates. He points to a misconception in Einstein's infinite future setup and proposes new spacetime coordinates tailored for interstellar navigation. Translation. Swap the map, change the routes. Myth. Gravity and electromagnetism are forever separate in practice. Koecki's claim. SEGUT, the supertelic electromagnetic gravitational universe technology theory, tries to blend them into a unified, usable framework, a sort of superintelligent blueprint for how the universe actually works. What does all this mean? Koecki builds a universe where space has structure, expansion can push you faster than light. Time travel isn't the prize at the end. It's a bold, contrarian roadmap for spaceflight and cosmology. But here's the tension. Mainstream physics treats the vacuum as a quantum field. Yes, but not as literal molecules you can shove for thrust. Relativity remains one of the most tested theories ever, and any FTL inside normal spacetime clashes with causality and known observations. Still, speculative ideas can be useful. They stress test assumptions, inspire designs, and force clearer questions. If space is more than emptiness, if expansion can be harnessed, what experiments would show it? What numbers would break it? Because in science, extraordinary claims need extraordinary evidence and extraordinary measurements. I'm not asking you to believe it. I'm asking you to think about what it would take to prove it, or to rule it out. That's where real discovery starts.